Welcome to Nerd Out at Spotify, where we bring you behind the curtain of the world's most popular audio streaming subscription service. Machine learning, open source, clouds, tabs versus spaces. We'll talk to Spotify engineers about interesting tech issues, big and small. Hello, I'm Dave Zolotuski, Principal Engineer at Spotify. If you go to Spotify's GitHub page right now, you'll find over 200 repositories. Most of those open source projects started as internal tools we built for ourselves to help us get our work done. So you'll find tools for processing huge amounts of data, tools that help teams develop for iOS and Android, and tools like Backstage, which help you manage all of those different tools. Of course, we also do a lot of work in audio and machine learning at Spotify. In this episode, we'll hear about an open source project that combines both. It's called Pedalboard. It's a framework for processing audio effects at scale in Python. It comes from Spotify's Audio Intelligence Lab. They originally built it to help them with their machine learning research. But of course, one of the fun things about open sourcing your software is once you put it out there, you never know how other people will end up using it. To tell us about that and more, I'm here with Peter Sobot, one of the engineers on the team that helped build and open source Pedalboard. Hey Peter, thanks for joining us.
Great to be here.
Let's start off by just hearing a little bit about you. Can you introduce yourself? Tell us about what you do at Spotify.
So my name is Peter Sobot. I'm a staff machine learning engineer here at Spotify. I work out of our New York office. And I work on a team called our Audio Intelligence Lab, which does, how do I describe this? Audio magic is a way that some people describe what we do. We do machine learning stuff on audio and music. So our team builds ML models that try to look into audio and look into music and figure out things like what language is this song being sung in, or what key is it in, where are the beats, all sorts of fun stuff like that. I am not myself a machine learning person. I'm much more of an engineer. And so I wound up on this team, and that's what I do every day.
I think it's interesting that you drew a distinction between machine learning and engineer as like completely different things, but I don't necessarily want to go there. Actually, I meant to tell you the story earlier, but the first time I ever heard of you at Spotify, I was doing some work in open source. Mm-hmm. And one of our coworkers needed me to add someone named PSO bot to permissions. So I was like, oh, we have a bot that does PSO? And apparently we do not. Apparently that is you.
It's a great joke because it comes up all the time. And at various different companies, I've considered creating a Slack bot that shares my name and has the bot tag next to it and looks like a robot. But it's really just me talking to people. Yeah, it's wonderfully confusing.
Cool. And so what does that mean you actually do day to day? You kind of talked a little bit about what the team does and the ML magic that the products on the team do, but what does your day to day look like?
It's a tricky question because really day to day, I'm either fully in meetings talking with a ton of different people, from product managers to researchers to other engineers, or I'm heads down trying to make something work in code. But what it effectively means for me is that my role is to try and bring some engineering to the team, which is mostly comprised of researchers, to speed up the research process and try and get all of the cool research that they're doing into the Spotify product somehow. And sometimes not in the product, but instead it gets open sourced or it gets published as a paper and stuff like that. But in general, I'm kind of acting as a bridge a little bit and the glue that helps make everything go faster and bind things together from research and engineering and product.
I got you. So that's kind of what you meant before when you said like an ML person as opposed to an engineer. You kind of mean the coding pieces of engineering versus the kind of researchy understanding ML algorithms part of ML.
Exactly. Yeah. I've started to learn a lot more about that. I've been on this team for more than 2 years now. So a lot of the ML knowledge has sunk into me now. But yeah, I'm definitely still an engineer first. And the ML is this new domain that I'm still working on getting better at.
What are some of the coolest things you think you've learned being an engineer, but being really close to the ML side and getting to poke around it from interest, but as part of your job?
Yeah, the coolest things about ML, man, when it works, it can do some really amazing things. And I don't want to overgeneralize because obviously it's a huge field with a lot of distinct approaches and research topics and things like that. But sometimes we're able to put together a product that really does something no one's ever been able to do before. And that's because there's been some research breakthrough or some bit of math that actually works out in the end. And when you apply that math at scale, that's basically machine learning. And when that gets deployed, people really look up and go, wow, we never thought that was possible. I'll give you a quick example. A couple of years ago, some folks on my team, before I joined the team, they put together what they call a vocal separation model, which is this holy grail in audio processing or in machine learning, which was that once you have an audio track or like a piece of music that has vocals and then has some instruments behind it, you can't separate those two. Once it's been mixed together, it's impossible to unmix that. But it turns out that with machine learning, you can get pretty close. And so my team published some papers on this and wrote some code and deployed this in certain environments. And that's the approach that most people are using now to doing source separation. And so now you can take a full song and actually break out, here's the drum track, here's the bass, here's the guitar, here's the vocals, and so on, which is mind-blowing. 10 years ago, no one ever would have thought this is actually possible.
Your team recently created a really cool project and you open sourced it. I think you called it a bit of math at scale that does awesome things. I want you to tell us about that.
Math at scale is a good way to put it. The project I've been spending some time on recently is a project we call Pedalboard, which is how do I describe this? Pedalboard is a really useful package for a lot of different reasons, but it is very hard to describe. I'll start with the boring angle of this. So Pedalboard is a Python package that lets you apply effects to audio and work with audio in Python in a way that's really natural and easy to work with, and also very fast. So that sounds boring, but you can do a lot of cool stuff with that. You can now write Python scripts that do the same kind of thing that you might want to do in, let's say, your digital audio workstation, like Logic or Ableton or something like that. You can now script all of that and do this at scale if you need to work with lots of audio files, or you can now do audio research really, really effectively because now you have tools that can handle all of these complex use cases. So we open sourced this and people seemed to love it. I was really surprised at the reaction. We put it out there. We said, hey, this lets you run effects on audio. And the community just went wild. I think we have more than 3,000 GitHub stars now. But it's had a great reaction in the community and people are starting to use it for some really neat things.
That's really cool. I definitely want to talk a little bit about what people are using it for. But before we even go there, why is it even called Pedalboard?
So we called this Pedalboard because we're borrowing language from musicians. And I'll start at the very, very start here. So if you're a guitar player or a bass player or someone who plays live music through an electric instrument, you probably want to change your sound in some way. A guitar player on stage playing electric guitar, they probably want to add some, distortion, some reverb, all sorts of cool sounding effects to their guitar. And the way they do that is with guitar pedals, which are little boxes that you plug your guitar in one end and you plug your amp in the other end, and it changes the sound of your guitar. And when people take those pedals and put them together, it's called a pedal board, and it's physically a board that sits in front of you on stage, and you use your feet to hit various pedals at various points in the show. So that's the analogy that we started using for this, because really what we've built is a pedal board in software. You can chain together effects. You can use any effect that you have on your computer, not just ones that come built in. You can tweak parameters, turn them on and off, all sorts of stuff like that. And it just looks a little bit different because you're accessing it in code rather than with physical boxes.
You also talked about it replacing, I think you called it a digital audio workstation.
Yes.
So now I'm on the one hand picturing a guitar player stepping on a bunch of pedals, and on the other hand wondering, what is a digital audio workstation?
So a digital audio workstation is a piece of software that most musicians nowadays would be familiar with. And this is because DAWs or DAWs are how you record your music nowadays. There's popular DAWs like Ableton Live or Logic Pro or GarageBand even, which comes shipped on every Mac. These all allow you to record music and then to change that music in some way, to chop it up and move it around and record multiple tracks. And crucially, one big part of a DAW is that you can apply effects to your audio, just like you would with a guitar pedal, or also how you would use Pedalboard in code. So DAWs are really, really great tools for doing that. And some people have even gone as far as to say they're another instrument in themselves. You can think of electronic musicians making extreme use of DAWs to make their music sound like nothing you could ever create without a DAW. And what we're doing here with Pedalboard is trying to take some of the power that's in that DAW and pull it out so that you can have more flexibility and more control over it. So you don't need to click buttons in a UI. You don't need to scroll around and do stuff with your mouse. If you want to script it, now you can script it with Pedalboard.
So now DAWs sound cool and the physical pedal boards sound cool. Why do we want to do this in code? If all these DAWs exist, how is that different from the software that is Pedalboard?
So the reason we built Pedalboard in the first place, or like our particular use case, is kind of niche. And I'll be the first to admit that. The reason we built this is because we do a lot of machine learning on audio and on music. And one common problem you have in machine learning is if you're trying to train a machine learning model to learn something about music, let's say you pass it a piece of music and say, I want this machine learning model to learn that this music is played in the key of C. Then it might learn that that piece of music is played in the key of C, but it might be learning the wrong things. It might be learning that it thinks that that music is played in C because it starts on a C, or because it sounds a very particular way, or because of its length, or other properties that are not actually related to what we're trying to learn here. And that's a problem called overfitting. I don't want to get too much into the machine learning side of things here, but that is a big problem, because then you take that model, you try to put that somewhere else, and have someone else use that to say, what key is this piece of music in? And maybe the model always says C. It's always wrong because it got too used to the training data that you showed to it. So there's an approach to getting around this problem, which is called data augmentation, which is where you take your song that you're training on, or your input data, whatever that input data looks like, and you change it just a little bit. So you might take that song and make it a little bit slower. You might slow the whole thing down a little bit and say, well, even though it's the same song, but it's slower, it's still in the key of C. And the model learns to ignore the speed of the song because that doesn't matter for detecting the key, for instance. Or you might add some effects to it. You might distort it. You might change how it sounds in various other ways. And none of these things actually change what you're trying to learn, but they help the model be more robust. And without even changing how the machine learning works under the hood, just by changing the data you're showing to it, you can make the model much, much more effective when you actually do deploy it. And it's much more robust to weird inputs and other changes and things like that. So we built Pedalboard in the first place to do this data augmentation so that we could have a set of training tracks, and then we could just augment them in different ways. And suddenly we had millions of examples we could train on rather than a couple hundred songs. And that was kind of a niche use case. But then when we built Pedalboard, we realized, well, we can use this for anything now. Like anybody who wants to do any sort of effects, the interface is pretty user-friendly. It's very easy to use. It's extremely fast. It's production ready. It's well, it works for us. Let's clean it up a little bit, put it out there and see what else people use it for.
I see. So if I'm understanding correctly, for your example, for something like learning playing in C, Pedalboard lets you then have a bunch of different things that are all in that same key, and they might be, I don't know, reverby or have any other pedal pressed, but it's still C, so that then the model has a bunch of other data that sounds different from the C, but is still C, and then it knows they're all C instead of overfitting specifically the data you had. Is that right?
Exactly. Yeah, that's totally it. A good analogy here is that this also happens in the image domain. If you're training some sort of machine learning model that wants to detect that a bird is in an image here or something like that, you might take an image of a bird and then rotate it by 45 degrees and say, that's still a bird. And the model learns, oh, okay, now I know that birds could be in any orientation in the image. We're doing the same thing here, but just for music and for audio.
What are the kind of research concepts that Pedalboard is based on? Like the really cool math bits that make this possible?
That's an interesting question because Pedalboard itself is based on tried and true digital signal processing. So we use it a lot in ML use cases, but within Pedalboard itself, we're not actually doing any machine learning on your audio. Pedalboard itself is really based on digital signal processing that's been around for probably 50 years at this point. So the idea of how to do an equalizer is something that you can find in a textbook from 1972 or something like that. But then we use it in a lot of ML use cases, and we've made sure that it plays nicely with all the ML tools, and you can import that code in your TensorFlow or in your PyTorch projects and things like that, so that if you want to reach for complex audio tools, it's ready for you.
So then you open sourced it. I guess, did you have thoughts on what people would do with it, or just it was a cool thing so you wanted to put it out there and see what happened?
A little bit of both, actually. It was really hard to tell how people might react to Pedalboard because on the one hand, it's a tool that has existed in different forms, right? There are other packages that can do similar things. This is definitely not a completely unsolved problem. So the real advantage we were bringing here is that this package is a little bit more polished, much faster, much easier to use, all sorts of stuff like that. And it allows you to do stuff in Python without really having to install a ton of dependencies or look up docs and stuff like that. So the benefit of using Pedalboard was not immediately obvious when we deployed this. But at the same time, we heard from other people who work in, let's say, machine learning research or audio processing and stuff like that. And they were always complaining about their tools in different ways. So they would say like, oh, I use this common tool, but it has this one bug or it has this one flaw that's making it really hard for me to use it. And I always have to work around it. I always have to write some glue code or something in my program to make sure that I work around this bug. And we thought, well, we could try and fix those bugs. And we have tried to fix those bugs in open source projects. But at some point, it might be worthwhile just making a better tool.
And so now people have problems with your tool and complain to you about it.
Exactly. It's like that famous XKCD comic from many years ago, which is like, there are 15 competing standards. I know, I'll make one to unify them all. Now there are 16 competing standards.
That is exactly the thought I had in my head when you were saying that, but I figured I would convince you to say it rather than me saying it.
Good.
So what are some of the use cases you've seen people use it for?
People have used Pedalboard for a lot of different things I haven't expected yet. So one neat feature about releasing this on GitHub is that you get to see the projects that are directly importing your package or directly using your library. I went to GitHub just a couple days ago and took a look at the 80 different projects on GitHub that are open source that are actually using Pedalboard in some way. And they're all doing really interesting different things. Some people are just playing around with it, and that's great. I saw someone building some sort of like a server-based app where you can send in your audio and it'll process it with a certain number of Pedalboard plugins to make it sound better in general. There have been people who have tried to integrate Pedalboard into various other apps. I've heard from a couple people who work at startups saying that they work with audio, and as soon as they found Pedalboard, their code got a lot cleaner and it was a lot easier for them to iterate and try new things. I heard someone using Pedalboard for something I really didn't expect. They opened an issue on the GitHub repo and said, how can I slow down audio and make it pitched differently? And I took a look at some of the repos online and what people were doing with this. And there were some people using Pedalboard to effectively make what I think are just like really vibey YouTube videos. Like they take a song, they slow it down, they make it really kind of like chill. I'm sure there's a genre name for this or something, but they make an edit of it. And then they seem to post that somewhere else on YouTube. And I thought to myself, I don't fully understand the culture involved here, but I love it. Unexpected use cases came out of the woodwork, and I couldn't be happier that people are using this.
Well, I guess that kind of ties back my earlier question of if a bunch of these DAWs exist as software, why do we need a library that does this? But I guess you're not going to take a bunch of YouTube videos and feed them through GarageBand. You really need something you can script with, something you can run something like Python code at.
Exactly, yeah. And this is something I've been kind of looking for myself for a long time. I've been using DAWs for probably more than 10 years now, just in my own music making and playing around and stuff like that. And I've always found myself in a situation where I think, oh, this is great, but I need to make this change to 10 different projects. And I don't want to have to open that project, save it again, make the change, do all of these mouse clicks basically, which take hours if you do them yourself. Why can't I just script this? And I've already used Pedalboard a couple times for use cases like that, where, well, I've got these 10 tracks that I wrote and I want to make them all a little bit louder, or I want to make them all sound a little bit better by applying this plugin. And then Pedalboard lets me do that in basically a couple minutes rather than clicking around for a couple hours.
Are there any other cool, either within Spotify or from people you've seen externally, use cases of Pedalboard that you want to tell us about?
So I've heard of people, mostly through bug reports, ironically. Like you find out how people are using a tool when they tell you that it doesn't work for some esoteric use case. I've heard a lot of people talking about this in research domains that I've never heard of before. So there's some folks using Pedalboard for, I think it's called ambisonics. There's this like surround sound audio research stuff that some folks are doing at some universities, and they're using Pedalboard. There's some other folks using Pedalboard for a neat kind of audio modeling that lets you place a sound around a user. So I think this is for VR kind of stuff. But let's say you're wearing headphones and you want to hear a sound as if it's right behind your head. There's a whole bunch of complex math and stuff like that people have put into plugins, and they've published papers on this kind of stuff so that you can take any sound or any audio file and actually place it behind your head by running it through an effect. I have no idea how that works. That is super, super cool stuff. But I've heard a lot of people on the Pedalboard GitHub page asking, it doesn't quite work well with this particular plugin, or there's some small incompatibility here. Can you fix it? And I've done some deep dives into that. And I'm like, wow, this is a world I didn't even know existed. It's really quite interesting.
You've said, make this sound better a couple of times. And I'm really curious about that. Like, are you just saying that as a kind of simplification of, I don't know, add 3 effects that I think sound better?
When I say make it sound better, I'm just talking about some generic effects that people put on a lot of stuff. So generally, if you're finishing off some audio or you're mastering some audio, you usually try to add the same stack of effects, or a very similar stack of effects, to make things sound professional and make things sound really polished. Usually those effects are things like a compressor, which will make the quiet parts of your sound louder and the louder sounds quieter. So it kind of like compresses the dynamic range, the volume of your signal. And that has a big effect on the human hearing, right? It sounds a lot better to us for everything to be louder like that. There's also things like basic EQs that you might want to add to try and make the sound more even across the frequency spectrum. Some people go as far as to add some mastering reverb and stuff like that to just give the sound a bit more space. I'm no mastering engineer, so I'm just kind of using the tips and tricks I picked up over the years. But things like that really have a good effect on the final polished sound of anything you're putting together, whether it be a podcast or a song or something like that. And there's also other third-party plugins that do try to do some of this automatic, make it sound better stuff. And one big part of Pedalboard that I haven't talked about yet is that you can load third-party plugins. Any plugin that you could use in a DAW or in another scenario, you can load that up with Pedalboard and turn those knobs and move those sliders just like you would in your DAW and apply that at scale to as much audio as you'd like or in a scripted, automated way.
So let's do a demo. Can you show our listeners what Pedalboard does?
Absolutely. So I want to start with a little caveat here. Pedalboard is designed for scripting and offline use and stuff like that. Pedalboard is not really that amenable to being used live. And that's because Python has a bunch of caveats when you want to use it in a real-time context. But just for this demo, just because I wanted to see if it was possible, I did hack something together. And so my voice that you're hearing right now is actually going through Pedalboard live in a terminal window that I have running on my laptop here. So hopefully you can hear me. Hopefully it works and it's not going to crash on me. But right now I've got a Pedalboard with a couple different plugins in it, and you probably can't even tell that this is happening because it just sounds decently good. But I've got a noise gate that's cutting out some background noise. There's a compressor to make my voice sound a bit more full. And then there's some gain on the end to just make things a little bit louder. But I should be able to just add another plugin here and see what that sounds like. So I've got this terminal window in front of me with a Python shell. And I've got an object in it, just a variable called p, and that's a Pedalboard itself. And it acts like a list. So I'm going to add another effect, another pedal to this list, effectively. So I'll do p.append. And just for dramatic effect, I'm going to make this a reverb effect. So you're going to be able to hear what this sounds like pretty much right away. And I'll pass that in and hit enter. And now, can you hear that?
Yep.
So now I'm in a cathedral or something like that, right? And all I did there was add an item to a Python list here that is being used as a Pedalboard. It's a little much though, so I'm going to tweak the parameters a bit. I'll grab that reverb plugin that I added and I'll do reverb.room_size equals 0.1. So now it's much smaller. And you hear that that's changed a bit. I'll change this again a bit more. I'll set the amount of the effect to be much smaller. So let's set this to 0.1 as well. And now it's very subtle. You can barely even tell. I do have some reverb on there, but it just kind of makes things sound a bit more full. So yeah, you can apply this to audio on the command line, in your scripts, wherever you want to. It's just this tool that you can use pretty much anywhere you might have audio like that.
That's really cool. I guess I'm picturing the kind of physical way that you'd have done this as like, you have a pedal and you can press it and it turns the effect on and off. But then the other thing you did where you did something like change the size of the room, I imagine, I don't know, there's like a knob on the pedal or you need a whole different pedal or something like that.
Yeah, it might be a knob on the pedal. It might be that you have a collection of different reverb pedals. I know some guitar players who have massive collections of these things. And in this case, we just ran a line of code to change that parameter value or to swap out that plugin for a different one.
And in the DAW example, I assume it's kind of similar. You have to do some clicking around to add this reverb and then some other clicking around to adjust parameters like room size.
Exactly. Yeah. Usually plugins have these really cool GUIs where there's like skeuomorphic knobs that look like real physical objects and you have to move those around and stuff like that. And there's all sorts of different interfaces as well. Some DAWs are simpler, some are more complicated. But in this case, it's happening in code, which is arguably more useful for certain use cases, certainly less interactive. But, you know, this is not an interactive tool. This is something meant for programmers.
I can see it being super useful. I mean, even in this live context, which isn't meant for, I can see it being a lot easier to like push 3 buttons, then like kick a pedal, then bend down and adjust a knob on it, then kick the pedal again, that sort of thing. It's like it's replacing having to have multiple pedals of the same type with a knob turned differently. Not that I have any idea what I'm talking about, but the fact that you could do those 3 effects in a handful of keystrokes, like a couple of lines, I can see being incredibly helpful, even in a world where you're trying to do it live like this, which it wasn't meant for.
No, absolutely. Yeah. And this is something that's been a problem for 20 or 30 years now. Like musicians, even as far back as the 80s, have had these huge pedal boards they need to deal with. They've invented all sorts of protocols and systems and connectors and things to hook them together in different ways. And it's not a solved problem, even now. It gets really complicated. Okay, so let me add a different pedal here. So Pedalboard comes with a built-in list of, I think, 10 or 15 different effects you can apply. This next effect is called a chorus, and it's, I'm not even going to describe it. I'm just going to show it to you. So p.append chorus, and now can you hear how my voice has changed?
Yes, that's cool. I don't know what I would call that, but I can definitely hear it change.
So that's one of the magic things about pedals. Oh man, that's really weird to hear. I'll turn that off for a sec. That's one of the magic things about all of these different audio effects is that sometimes you can't describe them. Sometimes you can only hear them. And sometimes you need to kind of like import a pedal from somewhere else or use something that someone's already put together because it's got that unique sound that you really need for your project or you really need to make your audio sound how you want it to. So Chorus does something under the hood here, but really all we're just saying is if you know what a chorus sounds like, Pedalboard's got one, and you can apply it to your audio, and it's really easy. It's literally just from Pedalboard, import chorus, and then you can use that on your audio.
And chorus is a standard, like somebody that knows something about music that isn't me would know what chorus means as an effect.
Pretty much, yeah. There's this set of 10 or 15 very, very common effects that most guitarists or electronic musicians would have heard of before, and chorus is one of those. Let me see if there's another one I can add here. Let me add a delay real quick. So this is going to sound like an echo, and I'll hit enter. And now, there we go. I've got a delay. And I can tweak all the parameters on here. Hold on. I'll add the delay one more time for dramatic effect, but I'll set the feedback high, which is one of the knobs we can tweak here. So let's set the feedback to 0.5, which means that every delay will feed back into itself and it'll be a longer chain. And I'll set the delay seconds, so the length of the delay, to something much smaller, like 100 milliseconds. And now I'll hit enter. There we go. Whoa. So hopefully that's like a really quick delay. But so I'm going to turn that off again.
I mean, it's really interesting that you talk about it as like a tool that isn't to be made live, and then this works so well and so easily as like yet another really awesome use case for Pedalboard that you completely didn't intend it for initially.
That's true. One big thing about Pedalboard is that because it's in Python, Python is not really a language that lends itself well to real-time use cases or to anything that needs to happen extremely quickly. And audio is a use case where you do need stuff to happen extremely quickly. For instance, if my code just blocked right there, or if there was any sort of delay, you would have heard a glitch. And it would have been like a really jarring, really kind of like show-stopping glitch. And because of that, Python, with its garbage collection and with its global interpreter lock and all sorts of other properties about Python, it's not really well suited to these audio use cases. So the secret to Pedalboard is that it's a Python project, but it's not actually doing much in Python. It's doing a lot in a big native C extension. And in that C extension, things are way faster. We can process this audio in real time. We don't need to worry about any of those delays. And I can do it live. But yeah, up until yesterday, I've avoided even telling people that it's possible to do stuff live because you really need to make that distinction, right? If you expect to be running the Python code itself live, that's a bit of a problem. But if you have a very narrow interface into the C++ world, then you can use the live code without any issues.
So I guess you said the bulk of it is C or C++. And based on the fact that you can do what you just did, it sounds like a lot of the actual audio processing and the effects are all done in C and C++. But you've been referring to it as a Python library. So why have the Python layer at all?
Well, Python is the language of choice for machine learning researchers at the moment. And it is very powerful. It's very easy to use, but it's definitely optimized for usability over raw power and raw speed. There's a lot of libraries you can reach for in Python to go faster if you need to. And the intent here is to meet people where they are. So if you're dealing with audio in Python, Pedalboard is a library you can reach for, and it's very easy to use, and it feels Pythonic. But under the hood, it does what it needs to speed things up to get the raw power that you actually need to be able to process audio quickly.
I see. So it's largely a C tool, but because the customers are all in Python, it's effectively wrapped in a Python wrapper so that all the ML researchers, the people that are actually doing this work on audio, don't have to have detailed understanding of C or C++ or how to run much more cumbersome native code and just run Python and go from there.
Exactly. One good example of that is that the fact that I just did a live demo in my terminal and the fact that I was able to run some Python code and play with a Python REPL or like a Python interface here is not something I could have done easily if this was purely a C++ tool or purely a tool in a non-interactive language like this. So Python's a good like glue language to hook together all of these powerful libraries like this.
I'm curious why, of all the languages in the world, Python would be the language of choice for ML research. Like I use Python for a lot of things. I have nothing against Python, but it's interesting that it's the language of choice for all of this kind of detailed, high-scale math research. It seems like, to your point about Python not being great at a lot of these kind of real-time high-performance things, if you're doing research at extremely high scale with high-scale bits of math, it wouldn't be the right choice, but I guess it is.
It's a great question, and I don't have a really great answer to it because like I mentioned before, I'm kind of newer to the ML world than I am to the engineering world in the first place. I think why Python caught on is because it is this great glue language and you're able to glue together different components. But also, it does have a good way to interface with C code. So if anybody wants to write a library that goes super fast under the hood, then they can do that and interface it with Python for the usability. So what I think happened, and I'm just guessing here, I'm not a historian in this topic, is that a bunch of people who wanted to work on ML libraries saw Python as that nice interface, and then they wrote some very high-performance C++ libraries like TensorFlow and PyTorch and things like that, and then used Python as the UI layer, essentially, for that high-performance code. And then folks who used those packages like TensorFlow and PyTorch didn't really have to care that there was C++ under the hood. They just said, oh, I use this because it's in Python, when secretly all the math is happening in C++ or even in other languages now. I know when you install TensorFlow, you actually install Fortran at some point, I think. Like there's some compilation happening somewhere. So using Python as kind of the lowest common denominator between all the people who want to work on this kind of stuff seems to have worked pretty well.
I think that makes a lot of sense, and that sounds like exactly what you did with Pedalboard. So we can stick with that as a story, as we don't have anyone at the recording right now that can tell us otherwise. But of the C parts that are kind of the details of the high performance parts, how much of it is unique code that your team built versus kind of other audio processing things that exist in the C world that you piece together and put this Python layer on? Like, maybe what I'm getting is like, what actually is Pedalboard, like the pieces that your team built versus things that exist in the world already?
So like a lot of good software, or no, I shouldn't even say that. I don't want to claim that Pedalboard is good.
I'll allow it.
Okay, thank you. Like a lot of software, Pedalboard is really just the piecing together of various components and then the writing of glue between those components. So Pedalboard is really a wrapper around this hugely powerful and fairly popular library called Juice, Juce, which is a C++ library used for building audio applications. Juice is actually used to build a lot of audio plugins. So what I mentioned before about just taking someone else's plugin and putting it into Pedalboard, that plugin might itself be written in Juice. Juice is also used for a lot of audio software, and people have built DAWs in Juice itself. So it's really this like huge library full of very, very useful utilities and DSP or digital signal processing and stuff like that for doing audio stuff. And then what Pedalboard is in itself is a bunch of interfaces from the C++ side to the very opinionated Python API that tries to make it look Pythonic and tries to make it very natural for you to work with these objects from a Python context. And then about 5,000 tests that just like test every part of this to make sure that it's rock solid.
I think the fact that so much of Pedalboard is tests, I think is also a really important thing to emphasize, as we so rarely talk about that specific aspect of it.
I'm huge into tests, and maybe my coworkers might disagree for some projects, but I think that if you're releasing something open source like this that others will depend on, you need to make sure that it's rock solid like this. And we're testing everything from, does the DSP do what it should be doing? Like, do the effects sound how they should sound? To, can you load other people's code into Pedalboard and does it work? To, will Pedalboard work as quickly as you want it to? All of these aspects are being tested very, very thoroughly on a bunch of different platforms and stuff, so that if you use Pedalboard, you don't need to worry about a bug in that library itself. You need to worry about maybe a bug in your code, or hopefully no bugs at all.
One more thing I wanted to talk to you a little bit about was just the process of open sourcing it and how that experience has been.
Open sourcing stuff at Spotify was surprisingly easy. There were checklists, there were people to get sign off from, there was all that kind of stuff. But at no point did anyone say, well, I don't know about this. I think that there's a reason we probably don't want to do this. Everybody along the way was super encouraging and super helpful. And then I think where the project got delayed for a good reason was I went to the product marketing team and I said, hey, I want to open source this. Can you help maybe with a logo or some branding or something? And I sent them a logo I made myself in Photoshop. And I forget exactly what they said, but I think it was along the lines of, oh, that's nice. We'll come back to you with something a little bit more ready for production. And then after going back and forth on that, we published. And the GitHub repo was open sourced one day and the blog post went up the next day. And then I think Hacker News picked it up and then other people online picked it up. Then the research community found it and the research community really loved it and started to flood us with some tweets and ideas. People got super excited. And that was basically it. Since then, there have been some check-ins to say like, oh, are people still using it? But overall, my team owns it and it's going along pretty well.
That's kind of the most, I'd say painless or like positive story I think I could have imagined you telling me. And I was expecting to get at least a little bit of pains along the way, but that all sounds great.
The only pain that I saw was really when they didn't like my Photoshop logo. It doesn't deserve to see the light of day. I fully understand why they did that.
What next? What are you hoping to do with Pedalboard open source from here?
We have a feature backlog, and there's a lot of things that people are asking for. But one big thing about Pedalboard that I want to be careful about is I want to make sure that we don't turn it into this kitchen sink library, that everybody asks for a small feature and we add that on the end, and we have to support that code indefinitely going forward. Pedalboard originally was, I think, only 500 lines of code. Like, most of that was C++, and if you're familiar with C++, 500 lines of C++ doesn't do that much. Like, there's not that much logic in there. So it's grown since then, and we've added some things that we need for various other reasons. But all in all, I think just making sure that we have a vision for the project and it's documented and we know when to say yes to features or no to features. We're just going to keep adding stuff as we find more useful stuff to add.
That sounds extremely pragmatic and completely lacking in amazing soundbite for me to use for cliffhangering marketing for the future. So I'll have to ask you, are there other interesting ML projects that your team is working on or things that you're looking to open source that I should be selling here?
We are planning to open source something soon, which is a machine learning model that can transcribe music for you. And I want to be very specific about what I mean by that. It can take a recording of an instrument and turn it into a list of the notes that were used during that recording and when they were played and so on. That's a problem that's hard to solve. And there aren't any really amazing open source tools for this. And we built something cool. So keep an eye out for that because we are planning to open source that right now. I was in a meeting about that just before this recording. And it's really exciting stuff.
So one last thing on Pedalboard. Now that we've talked about it so much, how does someone get started with it? If you've listened to this podcast and are now excited about seeing it, where do they find it?
They can go to github.com/Spotify/pedalboard. We've got a really big README with getting started instructions, and there's a guide to how you can start playing with it that someone very happily contributed to the project. And if you want to try it out, take a look at the examples. Apply some effects to your audio, play around with it, see what it sounds like. And if you have any feature requests or bugs that you run into or things like that, please feel free to get involved. There's a ton of people involved with Pedalboard, and we'd love to have more.
Cool. Well, this has been awesome, and I've learned a ton while still probably not knowing very much at all about this space.
I think you've got a great handle on it, and I can't wait to see what you come up with the Pedalboard.
I wouldn't hold my breath. What else do you nerd out about?
Well, Pedalboard is close to my heart because outside of work, I am a musician. Just before the world shut down for a while, I was in, I think, 3 or 4 different bands with some friends, both within and outside of Spotify.
Any of the music from those bands available somewhere where we could listen to it?
I did have some music that was on Spotify for a while, but embarrassingly, I took it down. But I might put it back up again later, or I will make better music and then put that on Spotify. And that'll probably go through Pedalboard in some way, shape, or form.
Thanks for listening to Nerd Out at Spotify. Next, we're going to be diving even deeper into machine learning at Spotify. So if you enjoyed this episode, make sure to follow and subscribe. Nerd Out at Spotify is produced by Spotify's Ted Vergakis and Seaplane Armada, who also wrote our fantastic theme song. I'm Dave Zolotuski. Thanks for nerding out with us.